Good afternoon, everyone. Welcome to the IRSM East Midlands branch meeting today, which we're really grateful for Jill Cusson's time. She's going to give us a fantastic presentation on reducing workplace noise, practical fixes that don't break the bank. Particularly focused on addressing noise at source. So last month, if you remember, we had an excellent presentation from Claire that was around general noise and hearing conservation. And this month, Jill's going to give us a brilliant presentation on practical fixes, so things we can all put in place to address noise at source rather than reliance on hearing protection. Okay, so over to you, Jill. Can you please add any Q&A into the chat? So if you've got any questions for Jill today, just pop those in the chat. Thank you all.
Thank you, Graham. Thank you for inviting me here today to talk about things I like to talk about. Noise, how to make things quieter, and things that don't need to cost lots of money. A lot of the time it's just little fixes. I don't usually like using that word hack, but it's almost sort of down that genre of what we're going to talk about today. And as you can see from the first slide here, this is in collaboration with the UK Hearing Conservation Association. So Claire invited me on as her sort of technical sidekick to follow on from what she was talking about. And as Graham said, it was more the noise in general, workplace noise, and more increasingly noise outside, whether that's intrusive noise or noise we choose to hear. And yes, I did see sort of Claire's presentation, and there's quite a lot that I get asked about and have to advise on when it comes to music and headsets and comms within the workplace as well. But today I am looking at focusing on noise control at source for long-term hearing protection. So usually the word hearing protection, we think of the things you put on your ears, but actually you protect your hearing by turning down the noise. Really, that's the key thing. So I won't go into it. My name's Jill. I'm a noise and vibration consultant, and I specialise in workplace noise. Done the other type, but I specialise in workplace noise and the HAVs, and they sort of work together. So that's why I just do those two. But enough about me. So just a little session overview. I have left, hopefully I don't ramble too much. So the plan is to leave a good session at the end, so we can have a chat about scenarios you have at work, and we can maybe just have a little brainstorming about some good ways of reducing those noise for you. But we're looking at why controlling noise at source matters. I won't go into too much detail there because I think we'll get it. They're going to set up a little practical toolbox of some control methods, common site place noise problems and simple fixes, because I imagine people listening here come from an array of industries, especially sort of consultants anyway. You'll find, like myself, 1 minute we're in a place that's making chocolate, and last week I was stood on an airfield measuring the noise exposure of staff near some fighter jets, which was probably more the fun side of my job, especially since the weather was so lovely last week. And we're going to have that Q&A session at the end. So following on primarily from Claire's really informative presentation, basically 1 in 3 adults in the UK are affected by hearing loss. And I think we're realising that 25, 50 years on, people are still getting hearing loss. Yes, we've got that historic case, but people are still developing hearing loss. Hearing protection has been around for a long time. We can argue technology of it, foams, materials, etc., that has evolved, but so has technology. So I wrote an article a little while ago, and it was like, hang on a minute, there's a lot of money going into PPE and the tech and the wearables, which is fantastic. But it doesn't seem to be in line with the excitement for the noise controls that are out there as well. And there's a lot of great companies that sell some amazing things out there that people just don't, I don't know, they don't seem to get as much coverage as the PP brands and things. So maybe it's the more technically minded rather than the big brand PP companies that, you know, great at marketing as well. Not saying one needs to push the other out. I just feel that it needs to be a little bit more balanced. I don't think anytime soon there's going to be lots of industries where they can eradicate hearing protection totally, but following the HSE focus, they want to be looking at, if you're going to use it, make sure it's at least being used properly, and that's where so much extra comes into place. But if we can get rid of the noise in the first place, or at least reduce that noise somewhat as much as we can, then there's less reliability on hearing protection everywhere. There might just be those zones. It's more relevant to those people where they go, yeah, I know this is loud and this isn't, so it's clearly marketed where they need to wear it and where they don't, rather than that blanket approach, which tends to, I find a lot of companies do this, and I get why they do it, but I usually need to spend quite a while with them to say, look, if we do noise controls here, then this is advisory and this is mandatory, and we can work it out how those people know to put it on and those people don't, etc. And it's very easy to put a cost against that, as in how much they'll be saving by not buying all the hearing protection everywhere. And they can focus on maybe better, more bespoke hearing protection for people, the molded or the cons built-in stuff that's out there, some great things out there, rather than just a blanket one plug is, or one ear defender, a choice for the entire site, which is amazing. Yeah, so the noise control, I think we're probably already speaking to the converted, the fact you're attending this session, and I'm not going to rant on, but it's less admin, isn't it? There's less making sure signage is up and then having to get people to go to hearing health surveillance and all of there's less waste from the plugs, there's less time spent selecting the hearing protection. It's just so much easier if it's nice and quiet, but if it gets noisy, then it's more noticeable than if, you know, something's already a really loud environment. How do you start noticing when things start needing maintenance? And that's usually the sign, isn't it, that something needs fixing, starts making a bit of a noise or a bit of a rattle. And especially in manufacturing and processing things, nobody wants a breakdown. So it's all of those benefits, but it's so much more cost effective as well. Because once it's done, it's done. It's not a yearly thing like your hearing test or your earplugs. So we know about the hierarchy of control, so I'm not going to go into that at all. So, but typically eliminate. So we're on to the noise control part one. I'm going to just go straight into this, and the terminologies can get a bit mixed up sometimes, and I do find that there are some companies that offer some great safety consultancy and assessments, and then they dabble, and then this is where it can get a bit messy. So not to frighten people, but just check before you suggest things. Everything is got a purpose, but you can spend a lot of money doing the wrong thing. So damping typically in this acoustic industry is a scenario where we are stopping those surfaces resonating. So a nice example would be when you put, well, actually people have got sort of resin sinks now and ceramic sinks, but back in the day where you had your metal sink, if that was just left as that pressed form, every time you dropped a knife on the draining board, it would make a racket. So that's why you have that really thick sort of resin mat that's stuck underneath the draining board, and then a big square stuck around the plug. So that's the sort of example you'd have for damping. And it's sort of, that's the resin type. You can also get a sound damped steel type product where the two pieces of the same metal are sort of adhered together. Usually they're the same weight as they were before, but basically instead of just that one piece allowing the sound to resonate through it, just like a cymbal, you just need to be able to put your finger on that cymbal and it stops that sound from resonating through it. In the case of the cymbal and the guitar string, we want that resonance, but for thin metal panels, we don't want that ringing. So if something's thin and it's impacting against it, we can stop that ring by damping that surface. As I say, we've got the don't think you can see my cursor or not, but the bottom left of the screen, you've got that curled up bit. So that's that sort of stick on heavy stuff that would go onto the side panels. But then if you're in a food grade industry, you can't really use that. So this is a demo I had on my LinkedIn. I'm surprised on how many training companies and the locker system that goes into colleges and schools and things and talks to them about acoustics, and borrowed this as well. So I'm just going to play this video. This is me trying to demo it for you. So I'm not suggesting everything's made out of thin biscuit tins, and I'm not suggesting that you go and buy lots of fridge magnets to then stick on the surface, but that gives you the idea of what happens to a surface when it's damp. So you have that metal hopper or plates where things are impacting against it, or things are moving where the plate is impacting against the frame or something. If that can't be adjusted and it can't be isolated so the noise doesn't travel through it, you can put some damping material on there. So I do work with one company and they're going to send me some samples for scenarios like this for when I go out and about. So if anybody does want a sample of some of the sound damp steel that I use, give me an email and I'll send you one out when they come through. I did give them a heads up, say, can I have a few? Because when I do chats, it's nice to be able to send it out so you can see it. And then if you've got your engineering team, you can actually show them something to have a look at. So on the right-hand side, we've got absorption. Now, this is where people can make a few mistakes. So this is an environment where it's been fitted into like an office. So that scenario where you are decorating your front room and all the furniture comes out and it's really echoey, a bit like this office at the moment, because we've just moved in. We need a few bits and pieces on the wall. So that stops the reverberant noise, that sound that's bouncing around, and it can get quite loud. So what it's doing is, instead of the sound hitting the wall and then bouncing back, it's hitting the wall, but it's actually going through that absorption. And because it's going to be a material where the sound waves can get in, and it'd be open cell foam, not like sofa foam or anything, but it's where there's holes in there, the sound waves can get in there, they'll hit the wall, and then some of them will try and come back. But through friction, those molecules are sort of brushing against the material, and that acoustic energy is dissipated as heat. Not like enough to kill the fire or anything, but that's that transfer of energy. So that's quite good. And normally if I was doing a training course, I'd say, but why would you think that you wouldn't actually put this up in a factory to reduce the noise of the operator? And hopefully you already know the answer is, it's a bit like putting an extraction system when somebody's bent over their desk grinding, where they've got like a little sander or something really close to the face, and then somebody's put the extraction unit above the top of their head. Their face is already going to be breathing that dust in, and the extraction will just capture what's already past them. So the same thing happens with the noise there. You stood near the tool or the machine, or in that environment where you're next to the source, your ears are going to pick up those sound waves, and then all the acoustic absorbent is going to do on the walls or ceiling is stop the noise bouncing around. So it's probably going to be easy to communicate a little bit better because there's less reverberant noise, and it might sound quite nice when you're walking down along that walkway where somebody's demonstrating, oh, look at all my nice acoustic panels. We've reduced the noise by 2 decibels on the walkway and not at all at the operatives. So when you're looking at the data there, it can say 20 decibels off, etc. But the 20 decibels off is that reverberant noise. It's not going to knock 20 decibels off your workbench or your breaker or anything. Hopefully that makes sense. But also, hopefully I'm not teaching you to suck eggs either. So that's the acoustic absorbent. Now, another material that's quite good, obviously not suitable for food environments, but one example of a good absorbent material is rock wool. And that's why it can get a bit confusing, because it's an insulation for heat, i.e. you put it in your loft and stop the heat escaping into your loft or out of your roof, but it's an acoustic absorbent because the sound can actually get absorbed into there and dissipate as heat. So Rockwool is a really good one. And you can get other materials similar to that, and they'd be used similar to, I mean, you wouldn't just line the walls with that. Usually you'd have like a perforated steel. You can get some very decorative ones that can go in the front of those type of things. So isolation. So these are all the type of things that are quite typical. Now, you wouldn't buy a bulk buy of isolation mounts to then put on all of the motors that you have on your factory, because there are certain things you need to think about, as in the weight. If you have like an isolation for anybody who rides mountain bikes or motorbikes, if you're setting up the spring for you to absorb those bumps, the spring would be set up differently depending on the weight of the person and how bumpy something is. So the bumpy being how the machine runs, and the weight of something being the mass, the weight of somebody being the mass of the machine. So if I lent my mountain bike to some of the people I know that are quite heavier than me, they would sit on my seat and they would literally compress that spring straight away, which means there's no spring left in that system. So the vibration is going to travel straight through. Likewise, if I sat on their seat, it would be rock hard, because my mass is not enough to compress the spring that they've used. So that bump would still travel through as well. That's why anybody who's into like racing cars and things, or any of the motorsport race suspensions, because it's not bumpy, they're usually a lot stiffer than road going suspensions because they don't need to absorb the bumps. So my point being is that you sort of need to have a bit of a think about the mass and the springiness of the material. So the examples here, it's anything from the actual springs. I mean, something where you're looking at a big press, you could have a big metal shape that looks like a Z. We could have two people stood on it, and it wouldn't make a difference. But if you've got something that's like 3, 4, 5 ton, that is actually going to compress that little bit of spring enough to absorb some of the vibration. And then you also need to have a think about how things run up. If you've got run up speeds, is it simply start or stop, or a bit like a washing machine where the spin cycle works up nicely, and then at that RPM needs to be safe, so that's isolated really well. And then as the spin cycle slows down, you hear it just wind down, and then just before it finishes, it sort of does a bit of a judder, and then it sort of finishes. And that's because this different speed is reflective of the different frequency that we'd be looking at. And at some point where that judder was, that was actually hitting the natural frequency of the material. So if we'd have picked the wrong material where the washing machine was spinning at that speed when it was juddering, that would be a disaster, wouldn't it? That would actually be quite dangerous. But luckily it just passed through that natural frequency because the speed was sort of slowing down. And you can have mounts, but if you're mounting something sort of sideways, you've got to look at that shearing effect. And sometimes when you put in isolation mounts under things, you've also got to think about the space, because now something's possibly going to get lifted up. But yeah, there's lots to think about, and I don't get too involved in recommending the type. I just know some good companies that I can say, look, these guys specialize in isolation mounts, and then they're the ones that can step in and do that. So barriers and screens, so these are pretty useful. This example here is a frame where there's just sort of some hardboard there, and where you've got something that's maybe just somebody standing, or just something that's not drilling, or just something basic, quite high frequency noise, something like that can work really well. I've put really small local screens, maybe the size of a suitcase, not thickness, just the width of the dimensions of a suitcase, just because when somebody's walking at head height, there's quite a loud motor, and just putting the motor in the shadow behind that little bit of a screen just means that when somebody's sort of working nearby, they're not exposed to it. So I think people think, oh, it's an enclosure, but it isn't. You can just do some clever shaped screening and barriers. This is where it goes a little bit more detailed here. So this is where you'd be looking at a full enclosure, and this is this is bespoke here. So in this instance, you can see there's the exhaust system coming through the roof, where you've got a silencer, which is quite key, because if you didn't have that, you would just have the noise in a box then coming out of the hole, so the noise wouldn't be reduced at all. And the doors, they're louvered because there needs to be that airflow there, but you can possibly see that it isn't just angled metal. You can see the depth of the doors because behind that there will be suitable fire resistant acoustic absorbent underneath each of those fins of the door. So the sound is going to be having to be forced through and round all of those features rather than just it being metal bouncing around and coming out. And a lot of things need isolating from the enclosure as well, because if we don't isolate them, then the sound will just resonate straight through whatever fixture you've got, and then it'll resonate off the panel, and then you've created a box that behaves like a speaker. So enclosures usually can be good if you do them properly, but I have seen people do homemade ones where they've actually just made things louder because they've gone, oh, you've got a small item and you've put it in a box, and now it's got a bigger surface area, so there's more noise radiating from it. And I think you'll see the examples of little music boxes. You've got been demoing these for years. The little music boxes that you turn and the cantilevers ping. If you want them to be a bit louder, they're usually in a plastic box, and that's how they become a bit louder. And then the good old fashioned, if you can't reduce the noise, do you need to be stood right next to it? Sometimes machinery where it's got exhaust, etc., it's around the back. So have a think about rotating things. Are you putting things in corners? If you're putting them in corners, then are they then using those extra surfaces of the corners for the noise to bounce back and then back into the area? That's why back in the day, before we had fancy speakers, we'd just mount them in the top corner of our bedrooms, because then we've got all of those surfaces to bounce the noise back into our bedrooms. And then if you know how loud things are, if you can't move them away, you can maybe keep people away. So you can just keep stepping back and working out safe levels and work out that zoning. And that's how sometimes you can have it where people cut through areas to say, well, actually, providing they just cut through this area and don't stop because you're not putting any notice boards there and things to encourage people to hang around, people are going to be fine. And then we've got the good old process change. I am one of those sort of toddlers where I'm just like, I've seen this used it. Why do you particularly use it that way? What's your thinking behind this? Explain to me why you do it this way. Blah, blah, blah. And I learn a lot, and I learn some very clever ways things are done. And sometimes just my lack of knowledge on a particular thing I've come across, usually because I've seen similar things done different ways, but because the industry's never come in contact with each other, they wouldn't know. That my questions, they say, oh, well, usually it's that we've always done it like that, but that's not that often now. It's a case of, oh, we do it like this because, and then I'm like, right, okay, I won't suggest they change it that way then, because that's why they do this. So it's a great way to learn about the process, and the staff themselves, they usually have some really good ideas, or they've worked elsewhere and they go, well, actually, I worked at this company before and we used one of them and it was way quieter. So these, they're golden nuggets, aren't they? But yeah, well, so one example was a company. They had regular customers, really great company, had been around, family run, nobody left there. I go back every few years for bits and bobs, and I still see the same faces, and it's so nice. And it's nice to see as things are progressing, safety-wise, over the years as well. And when I first came in there, I was asking about the surface, and so we prep this, we do this, and then we sand it, and then they paint it, and then they do the X, Y, and Z. And I was like, there's quite a few different technologies that have happened going forward. Is your client still needing you to do that? And they're like, what do you mean? They'd tell us if they didn't. And I said, well, actually, sometimes procurement just repeat an order. And if you've been doing this for years and they've just been repeating the order, they've probably not questioned it that much, especially if it's just sort of an admin person that's doing all the repeat order things in procurement. Because I was saying you don't necessarily need to sand to prep a surface anymore. They might be using or be willing to use a different paint. They might not know about it. So there's quite a few paints now, the primers and things, they can adhere better. And you can also get ones where it's sort of like called e-coating, and electricity is used to encourage the paint to bond to the metal. It's quite clever. I won't go into too much detail here, plus too much detail is beyond my knowledge, but I know enough to sort of ask the question, so that it reduced a lot more noise for them and Havs. I was looking at both anyway, because it turned out that the company did use this new paint, not the e-coating style, but was using a new style of paint, and that surface buffering wasn't. They didn't realise that the surface of the material going out was then having to be sanded for them. They just thought that was the level before, and that they didn't need to polish it. But no, it came through really well, and then they were actually roughing it up a bit for them to paint, and they're like, oh, we didn't realise you were doing that. And it's like, no, we don't need you to do that. It wasn't a massive difference of the price for them. The company wasn't too bothered about the quote change, but it meant things could get turned around really, really quickly and at last minute if needed. And it sorted out a lot of the noise and the dust and Havs, particularly the Havs. So that was just a little bravery with saying, why do you do that? I've seen that we've looked at this. A lot of companies will say, the trouble with that is, and they just think that's going to be too much work, we've always done it this way. But if you investigate and you know where companies have done it, then you can usually say, well, actually, I know companies similar to yours that does this, etc. Then that pricks their ear up, because usually they could be competition. So they're thinking, hang on a minute, it might be worth us knowing about it. And buy quiet. So that's an obvious one, isn't it? Try and look for quiet options when you're looking at bringing in new kit. Right, so I've got some scenarios here. So this is for those people that work in areas where there's products. This happens to be a food one, where you've got to actually think of hygiene as well. So this was pretty loud. This product was chilled as well, so it's quite hard. Sometimes they're frozen as well, they can be quite loud. I didn't leave that too long. I think my office neighbours wouldn't be too happy with that. But you can see the conveyor was fine. There was the conveyor was dropping quite high, but it was also dropping onto thin metal that was behaving like a bell. So absorption not really needed in this environment. The person was stood right next to this, replacing the baskets with the bags for the food. So in a food environment, you can use like acoustic panels and things if needed, but in this instance, it was the damping that we'd use. So the not like the resin type stuff that would go into your sink, but a sort of sound damp steel, and it wouldn't need to be on the side where the product drops. It just can be on the other side, because if you think when you stop a cymbal, it doesn't matter if your thumb's on underneath or at the top, it stops it the same way. You need to make sure that surface is clean and you're covering about 70% of that surface. Or potentially, if a company was making lots of those types of pieces, then you could actually make it out of that material in the first instances. But that would be a simple retrofit. And you're looking approximately about £50 a square metre. So you can either order it in to bespoke shapes, or you could just get it in. And if you've got access to like an engineering team where they've got a guillotine or something, they could just cut that and fix that, and that'd be gone, totally gone. And if you've got sometimes where places are making what sort of metal parts or things that are heavier, that can actually wear quite a lot over the bolts and split the metal over time, surprisingly enough. So it does preserve that a little bit better as well. So yeah, so process change as well. If that conveyor was running a bit faster, so it's throwing things there, we could be looking at that. And then say potentially the height as well, because if things are dropping higher, they make it there's more force when they hit the panel. So they're all sort of things you look at. So that can work quite well when you've got presses and things where you've got products dropping out of the scrap and it's sort of dropping at height. So, or into chutes and things. So compressed air, this is yeah, a big one. Always question, why has it been used in the first instance? Do we need this? Are people, if it's exhausting, yes, then that's a suitable thing. But is something exhausting too regularly? Is that because there is normally I don't know, an example, a big compressor, and it's running lots of workbenches that typically would have lots of tools on, and then on Saturdays you've only got one person doing it, so it's, you know, it's dumping the air quite regularly, then you'd probably want to alter the setting because you're paying for that compressed air. Yeah, so have a look. I'd say the exhausting air, that's important, but if is it actually set at what it needs if it's exhausting it regularly? Sometimes lower PSIs and restrictions can be fitted where you've got air guns and things. Typically, it's quite high frequency noise, so it can be very, very loud when you're really close to it, but doesn't necessarily make a difference to somebody further away. But if you've got enough unsilenced exhaust and air releasing, then it will make a difference to the environment. And it's good practice as well. And also encourage things to be turned off when they're not in use as well. I've had conveyors where air has been used for rejecting products or every amount of something, and it still had this sort of sensor on the conveyor where it was going really quite loud, and there was operatives there, and I was thinking, what even is that doing? And I asked them, I said, do you normally have different products there? Yeah. And I said, oh, what's this? Normally it looks, is it reject? And they went, yeah. And I said, is it typically for this? And they said, oh no, it's for a different product. And the HSE lady and the engineer were sort of chatting, and I thought I'll just go down the line and have a look at a few more things. And she said to the fella, do we need this? You know, can we sort this out? It doesn't need to be run. And the engineer had just gone, oh no, we can't do that. And I picked my ears up and I looked at him and I sort of did that frown as in, do you just tell her that that wasn't something you could fix? And then he sort of like readdressed what he was saying. He said, oh, well, I'd have to look into it. And then I sort of did another effect. I'm not very good at hiding my face sometimes, but I was in a, really, you're actually going to fob off? And then he sort of moved on. He's like, oh, well, and I was like doing the, come on, I'm literally watching you lie to this lady straight away. And he went, I'll tell you what, I'll sort it out now. And he tried, he was just literally going to bombard that person with, no, it's going to be too much difficult. And he was like, he just came in and disconnected it and plugged it. But there's so many things where I'll just leave that on because then I've got to refit it or not. And if people don't necessarily know about what they're asking, somebody saying, no, that's too difficult, they'll go, oh, right, okay, and then leave it at that. I'm not saying all engineers are like that, because the majority I meet are really, really accommodating. And to be fair, in this instance, I did speak to that engineer a couple of days later because it was a big site, and he just went, sorry, you caught me at a bad time, I was really busy and stuff. And I was like, yeah. I said, look, we're all trying to help everybody, and obviously wasting air as well affects everybody's scenario, doesn't it? Because the company's wasting money. So I don't think that was a typical thing, but that can happen as well. Things not been turned off, just left running. Even conveyors, to be fair, are sort of diverted away from the compressed air noise topic. But one scenario where there was a conveyor sort of run quite a bit and things get diverted a different way, and there was like machines saying, why is that running? Is that going to come online? Is that stopping? Is that having to cool down? What's that? And the engineer laughed and he said, the honest answer, Jill, we don't turn it off because it's that old, we're not sure that it'll actually turn back on again. And I was like, well, fair play, that's a very honest answer. And I was like, right, okay, well, if that was contributing to this area being purely hearing protection, then I'd really be pushing that. But yeah, you really need to look at getting that replaced, or so that can be turned off, because that's not really the best of excuses why something's left running. Right, so this is another scenario where there was this roller and things kept sticking onto it, and they'd fitted, you can see some like just hose, potentially clear hose, a bit like your garden hose but a different colour. And my question was, why is that being used? And because sometimes it's like, oh, that gets stuck, or that's this, or this happens. And then if you think something's getting stuck in a place, then can you use something to divert the product a bit further upstream to make sure it doesn't end up in the place where it gets stuck as regular? So yeah, so this hose simply needed replacing with a suitable hose. You can see it's a bit of a DIY thing. It's fastened to a rail. There was 2 of these, one at either end of this roller, and this was quite loud. I say a suitable hose that'd be a lot quieter, lower PSI. They'd literally just used it to the normal airline available in the area, and turn it off when it's not in use, which they did do. And that was how I was able to get a measurement. That I'm just going to play the audio where it wasn't, the machine was running and then the air kicks in. And this was just one of the air hoses. So that was a jump of a nice convenient 10 decibels. So it was 80, 81 at the operator's location. He did move around, but primarily we stood here. And when that one hose went up, it jumped to just over 90 dB. And as I say, there was sometimes 2 hoses running on that if there's a particular product going through. It was just that line because, see, if that's being used elsewhere, but it's like, no, we can get that sorted. And there's a few other sort of scenarios I've looked at to say, look, why is this sticking? Why is that? And I've said, let's address that as well. And as I say, different things further up the line, but this is simple. And even if they still had the air and you could hear it, you could have some clear perspex screening in front. So my camera is literally just, my phone is pressed against the guard there to take that picture. So there's already some guarding, but you could have some perspex there, and that would help screen that sound a little bit as well. Nice and cheap. Circular saw on a workbench. Metal is usually the loudest thing. So why is this being used in the first instance? So I ask that. Few sites, if they're getting bespoke pieces in, can you just get them ordered in at the right size? I know a company that fits out sort of trailers and Bowsers and things onto wagon chassis, and they had to fit those the safety rails that go in between the wheels to stop cyclists going in between the wheels. They're a set length, a set size, etc. So they now, instead of having the longer pieces, just buy them in at that length and with the holes already put in there. So that's reduced quite a lot of noise and vibration as well from them not having to cut it. And in the instance of cutting, especially like metal, you can get some really good cutting blades, and it's all about the shape of the teeth and the holes there to stop that sort of aerodynamic noise, but also that mechanical noise, that sound resonating off that blade. You get like different tips and things. So they're quite a bit more money, but the cut is much better and they last a lot longer. So while the initial sort of deep swallow with the noise and the quality and the cut, etc., can make a big difference. Even just keeping something sharp, when you've got tools that are shared by people, then that's where that can happen. Things don't get sharp, or where you've got it where somebody used a wood saw to cut metal and all sorts of things. So I've seen some stakes and some rusty things. So things need to be kept in good condition. And what type of bench is it mounted on? So sometimes it can just be wooden benches and metal benches, and the sound can actually sort of resonate through them, not just the cutting, but also just any of the product getting put on the bench and banging around. Screening can help to stop that high-pitched noise traveling to other people in the area. And what sort of is that extraction noise looking at? Are the extraction hoses in a good spot, or are they like the equivalent to you blowing over the top of a beer bottle, creating any whistles, or are the hoses all nice and smooth? And have they put it in a nice metal wooden box or metal box to help with the extraction? Because sometimes you just have like suction coming out of the box. And is that either helping or creating a speaker and making things a lot louder? And the most common themes across industries are the layout and installation, which can be an overlooked factor of things. So just having a thing about how do you get products A to B, and that's sort of what gets focused at. It's like maneuvering one thing in here and out there. but then not thinking, hang on a minute, that's something that's really loud that's now just got put in an area that was not a hearing protection zone, and now it is. And we've got loads of people in here, and really it didn't need to actually be in this area, or we could have used a divider. Engineers can obviously buy things in, motors and various power packs and the hoods we saw at the bottom of the conveyors and things, and they can do a really good job if they sort of take care. And typically you've got teams that can solve problems better, but things can go a bit wrong. As I say, you can suddenly get people putting the absorbent in, or you can get people building the housing over the boxes, or you get a really quiet motor, but then it's rigidly mounted onto a big panel on the side of a enclosure, so it's then radiating off that metal surface. So it can be quite a key thing here. So this one, in general, there's just pipes. It's a little water treatment plant. This shouldn't have been happening, but this was just poor installation and a bit of maintenance as well, to be fair. But I was like laughing. I was like, oh, I'm so excited to be able to show this to people. I did get permission, but it doesn't show, obviously, the client anyway. But this is quite special with how loud it was. So that was a little diaphragm pump, and yeah, so you could see that there was quite a few things going on there that were causing a heck of a lot of noise. So there's a little bit of that that needed some maintenance, because it shouldn't have been knocking, and it wouldn't have knocked that loud, but it was only because it was moving the pipe slightly that pipe that was quite rigidly mounted was then knocking against the structure of the building that was then corrugated metal and a metal frame. So it was like somebody with a big rubber mallet hitting the side of that building. You could see that isolated the bottom of that pump, which is great, but that was moving quite a lot. And so that needed servicing, and potentially they could look at an alternative pump as well. But yeah, that was pretty loud, and that was just somebody had not really thought about the leg bone getting connected to the foot bone sort of scenario. And that is definitely where sort of not just maintenance, but isolation was important there, because you don't want things rigidly mounted to roofs. So your low-cost wins, we're typically looking at your maintenance, fixing air leaks. I mean, that's expensive. Turning things off when you don't need to run them, using what's already on site. So what I mean by that is you can use sort of screening. There's one company that was in causing a lot of problem with some of their jet washing and sandblasting at the time with neighbours, and they're actually a container company, and they've been quoted just over £250,000 to build acoustic screening to mitigate this nuisance. And I was saying, those containers that you have at the bottom of the yard, you know, how regularly did they need to get moved? And they said, oh no, they're just there, whatever, we're not using those ones. And we designed a massive 3-container high horseshoe for the other container to get taken in with a forklift and the person to work on it there. And then we just sort of fill those gaps with really heavy rubber and things. And that was on site. And it fixed it, and they used it on a lot of their other sites as well. I should have asked for like a 1% commission, shouldn't I, of doing that? But so this maintenance, so this is just I'll play the scenario. But there's quite a few squeaks. So this is a very, very small motor, but it was actually produced in 97 dB. There's only one operative there, but hey, that's one operative and they all count. And if small motors are allowed to get that loud, then it's just sort of setting up best practice. And that motor was about the size of a kiddie's shoebox. So that was really, really loud. This one, sort of metals and squeaks and things, just necessary. It just needed more when it was fitted back together again, just a little bit of time and care. So just, that was like a way ahead. And the last one here. So this is an environment where product is taken from one area and it travels along ducts and pipes and it goes up into the ceiling, where it then goes into various hoppers, and various things are sort of mixed. And this level was actually taken on the floor where the operatives are, but the operatives could be up on the gantries. And this is where there's basically lots of air exhausting and vibro conveyors and everything. But they've just been left to just get loud, really. And I think with people wearing hearing defenders, they don't necessarily notice the noise, especially if their ear defenders are too good. Everybody's over. So yeah, and there's lots of air going. So I'm suggesting things that don't really cost the earth, but when you are going to spend money and investment is needed, you do need to really take care, because you don't want to be making assumptions just because something on the roof is that's the loudest thing on the roof, that must be what's causing a nuisance to the neighbours, and they're complaining, they can't sleep. That is not necessarily what's keeping them awake, so just be careful. Your enclosures obviously need to be suitable. The minute it's like a bucket works really well, but the minute you've put one hole in it, it's not as good. So you need to be really careful, because you can buy your enclosure, but then you need your maybe lighting, lone worker alarm in there. You might need a sprinkler system. You might need ventilations. You might need like emergency locking systems, all those things that these different people then come and drill holes and put their cables through and things. So you can spend a lot of money with enclosures that can be as good as taking 30 decibels off a machine, but then they're as good as just putting something in a normal room. Yeah. Make sure that you've got a robust purchasing policy in place, not just having it where companies say, yes, we consider buying quiet machinery. It's like, right, and that's it. So just have something a bit in place, and that can really help. And just to wrap up with the takeaways, just address that noise at source if you can, and then go up the line. Once you've got the loudest thing, then that might highlight there's something else there that you couldn't hear, and then just continue that way, really, go around that circle. Get the engineers and operatives involved early. They can provide quite a lot of insight, but then you've got their buy-in as well, so usually they'll want to see it through, and then when it appears, then the operative isn't sabotaging it. Don't forget PPE is that last line of defence, because it is pretty unreliable, really. And just think of all that time you've got to dedicate to make sure it works properly every day for every person. That's just exhausting. That is some very good training and repeat training. And don't just provide generic training as well. You do get the ones that's, it's good. There's some good ones out there, but you then still need to say, but these are our noisy sites, and these are where you would get our hearing protection from, and this is that, and etc. And make sure that hearing protection that you do use has been selected using the the acronym that Claire mentioned that the HSE are promoting. And hearing protection isn't suitable for everyone, so let's sort of pretty much get rid of it altogether. So other than what's the noisiest process in your workplace and why is it still there, I might have left it a little bit too late to do some questions. Sorry.
That was brilliant. Thank you, Jill.
Sorry, talk too much.
No, not at all. Really, really great. Honestly, I certainly I think it's brilliant to include case studies and the amount of video you included that brings it all to life. And yeah, just some great, sensible tips that we can all take away as well. I think important to have those takeaways that most people can apply. Talking about getting purchasing involved, your maintenance teams, these people are all friends in the business, hopefully, or if they're not, go and make friends and get them involved. Yeah, so absolutely brilliant. Thank you. I don't actually have any chat questions that have come up. Catherine says, thank you very much. Really informative and helpful. Great, sensible suggestions. I'm certainly echoing that. Yeah, I don't know if anybody wants to put their hand up right now. We have about a minute left.
Well, if they're
Um,
not your members anyway, if there's anybody with a specific issue, that they're just banging their heads against, just, they're happy to drop you a
you put
line
your
and just say,
contact
look, Jill, any
details up.
pointers?
Brilliant. Thank you, Jill. Really appreciate it.
You're welcome.
Okay, we'll draw it to a close.
Thank
Thank
you.
you very much. Thank you.